Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. Yes, I am going to start what analog circuit, inverting and non-inverting operational amplifier. And it is a part of monsoon series, that is GATE 2024 rankers, guys. Okay, let me know that everything is fine. Yes, please. Is it okay? Okay, guys. Now, that as you know, this topic inverting and non-inverting operational amplifier is important for all competitive exams, whether it is GATE exam, engineering services, ISRO, DRDO, BARC, and number of applications of this inverting and non-inverting operational amplifier. So stay tuned with me and then you will get the idea about the ideal condition and practical conditions. Okay, and what is the differential amplifier based on inverting and non-inverting operational amplifier, guys. So I think everything is fine. Please inform me. Okay, I think now everything is fine, guys. Okay then. Now, this is my experience. I am having 22 years of teaching experience and these are my ranks in engineering services exam, 16 in ESE 2005. AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams. Now guys, this is for you, master plan to conquer GATE 2024 in 6 months. Live interactive workshop live on 1st of August at 7:30 PM. That is by Abhinav Negi sir, MTech from IIT Delhi and 11 plus years of teaching experience. You can join this workshop if you want to get the idea about workshop, and if you have any questions then you can ask this question on this workshop, guys. Then second important thing, if you want to start your journey with us, then you can give national scholarship test for GATE examination, get up to 90% off on our program on 30th July, means this Sunday, and window will be open for 12 hours 9 AM to 9 PM. बहुत टाइम है, दीजिए टेस्ट और अपनी जर्नी हमारे साथ स्टार्ट कीजिएगा. ओके, और ये है राइट टाइम टू स्टार्ट योर प्रिपरेशन. देन फर्स्ट ऑफ ऑल, व्हाट इज द कंटेंट हियर? व्हाट इज ऑपरेशनल एम्पलीफायर? जस्ट गिव मी द आंसर इन कमेंट्स बॉक्स. व्हाट डू यू मीन बाय द ऑपरेशनल एम्पलीफायर? राइट, आई विल गिव यू द इंट्रोडक्शन. देन व्हाट इज द इन्वर्टिंग ऑप एम्प, आइडियल कंडीशन, प्रैक्टिकल कंडीशन विद क्वेश्चंस. Different types of questions we will solve. The non-inverting, ideal, practical with questions, and then finally differential amplifier, that is CMRR, common mode rejection ratio. What is the difference gain and what is the common mode gain? Finally, basic idea about voltage to current converter. Okay, then are you ready, guys? Everyone? Okay, give me the comments in comments box. Tell me. Give me 1 minute only. Okay, the next thing, operational amplifier. What is operational amplifier? First of all, you may get what MSQ on that. It is basically a voltage amplifier. There are 4 types of amplifier: voltage amplifier, current amplifier, trans conductance and trans resistance. So it is basically a voltage amplifier, right? Now second important thing, it is originally invented to execute the mathematical operation, addition, subtraction, multiplication, division, logarithmic, log, anti-log, and that's why it is called what? Operational amplifier. Then guys, then internal power consumption is very low because input resistance is very high and output resistance is very low, negligible, and that's why it is a ideal, just behave like what? Ideal voltage amplifier. For ideal voltage amplifier, input resistance should be infinite and output resistance should be 0, guys. So that is the characteristics of ideal voltage amplifier and ideal operational amplifier. Then normally operational amplifier work in 3 modes: inverting mode, non-inverting mode, and what? Differential mode. In inverting mode, the phase shift is 180 degree. and in non-inverting mode the phase shift is 0 degree, and in differential amplifier output is proportional to the difference of the two signal. Okay, so one by one we will discuss ideal condition and practical condition, guys. Okay, then Dave, everything is fine now? Okay, then 1 minute. Yes, please. Okay, now your comments are visible to me. Now, inverting operational amplifier means there is a 180-degree phase shift when we are giving input to this terminal. Okay, then at this terminal there is a 180-degree phase shift, and here we are getting the output. For ideal condition, as you know, the gain of the system is minus RF by Rin. That is the minus RF by R1. RF is called feedback resistance and R1 is called what? Coupling resistor. So that is what is the phase shift? 180 degree because of this minus sign, and that's why it is called inverting operational amplifier. But remember, this is for ideal condition. Ideal condition means we are assuming operational amplifier ideal, infinite, and that's why the virtual short concept is valid. Now, if the question it is given that it is not an ideal operational amplifier, then what is the solution? Then for practical operational amplifier, guys, remember, I am not going to derive it because in my previous session already I have derived. You have to revise this gain. Just again I am writing the gain. What is the gain? Is given by V0 by Vs, that is equal to minus AV beta. AV is the gain of the open loop op amp. 1 plus AV beta into RF by R1. That is the gain for practical operational amplifier, inverting operational amplifier, where beta is given by R1 upon R1 plus RF. This is R1 and this is RF. Okay, so that is the value of the beta, and this is the exact, we are saying that it is the exact solution of inverting operational amplifier. Okay, then if any question is asked, for example, let this is the question based on what? Practical operational amplifier, then how we can get the answer? This is the basically a inverting operational amplifier. The inverting op amp shown in the figure has an open loop gain of 100. If the open loop gain is not infinite, means it is a practical operational amplifier. Practical operational amplifier. Then what is the feedback mechanism? First question. Second question, what is the gain? What is the input resistance? And error in approximated calculation. This is actually a MSQ. Multiple select question. Multiple select question means what? Yes, sir, how the voltage will be amplified? Okay. Now, Dave, you will get the answer for that question, that when we are giving the voltage, what will be the output? We have to find the output across what? RL. When we are connecting the resistance RL, right? Then you can find the current. Second thing, we are going to find the output in terms of input. That is ideal condition, it is given by minus RF by R1 into what? Vin. This is the case. So that's why we can say output is amplified version of the input. Okay. Then now what is the feedback mechanism is inverting operational amplifier? Remember, feedback mechanism is voltage shunt feedback, and that's why this statement is wrong. What is the exact gain? You can find by using beta. First of all, find the beta. R1 upon R1 plus RF, 1 by 11. Then you can find the overall gain, minus AV beta upon 1 plus AV beta into RF by R1. What is the beta? 100 into 1 by 11 upon 1 plus 100 into 1 by 11 into RF, 10 by 1, RF by R1. Now please solve this and you will get the answer less than 10. That is what? Minus 9, nearly equal to minus 9. So in this case, you have to use the exact answer. So this is the exact one because the gain is not infinite. Third thing, what is asked? What is the input resistance seen by? Under ideal condition, the input resistance is R1. Remember, under ideal condition, the input resistance is R1. Okay. But under practical condition, you have to apply the Miller's theorem. So what is the Miller's theorem? Under ideal condition, this is 0, and what is the input resistance? 1 kilo. But under practical condition, when we are applying the Miller's theorem, when we are going to apply the Miller's theorem, then this is minus, this is plus. This is ground, and that is R1, and with the help of Miller's theorem you can break 1 minus AV, and here this RF is breaked. What resistor is here? That is RF, right? AV upon AV minus 1. Okay, and that is the case, guys. Now, here the AV is what? Minus 100. Why? Because we are taking the VI is equal to Vn minus Vp. This is the negative terminal voltage, this is the positive terminal voltage, and we are taking VI is equal to Vn minus Vp. When VI is negative minus positive, then always AV is what? Negative. In the question it is given minus 100, but you have to take it what? 100, minus 100. Then put here. So what is the input resistance up to this point? The input resistance is given by R1 plus RF upon 1 minus AV parallel to what? Infinite. Because up to this point the input resistance is infinite, right? Parallel to that, then you will get R1 1 plus RF 10 upon 1 plus 100, that is 101. Minus minus plus 101, and you will get nearly equal to 1.1. So this is a question on what? Practical inverting operational amplifier. You have to apply the Miller's theorem, break this by using the Miller's theorem and get the answer, and then you will get 1.1 kilo ohm. So this third answer is also correct. Third C option is also correct. Error in approximated calculation will be 11%. Always remember, when we are calculating the when we are doing the approximated analysis, error, how we can find the error? Then one minute. Okay. Now, to find the error, 1 upon AV beta into 100%. This is the error in calculation. So what is the AV here? 100. What is the beta here? 1 by 11 into 100, and therefore error is 11%. Directly you can use this formula, and that is a 11% is the error for this question, guys. Approximated calculation will be 11. So my dear friend, in case of MSQ, you have to go through each and every instruction, or what is the every options, whether A is correct, B or C or D. So in this question, B, C and D all are, these three options are correct. So this is about inverting operational amplifier. Now, non-inverting operational amplifier. So what is the non-inverting operational amplifier, guys? Now watch that. This diagram. Yes. This is a non-inverting operational amplifier. Here we are giving input to the positive terminal. There is a negative feedback. And normally we are having this type of diagram. We are providing the feedback here. That is V0. This is RF. This is R1. This is ground. And this is Vs. Okay. So this is called non-inverting operational amplifier. And what is the gain for the non-inverting operational amplifier? 1 plus RF by R1. 1 plus RF by R1 by using the virtual short concept. So this is the standard answer. But under practical condition, what will be the gain? When operational amplifier is not ideal, then in that case, the gain is AV upon 1 plus AV beta, and where beta is R1 upon R1 plus RF. And beta is what? R1 upon R1 plus RF. Please revise all this concept. This is a gain for practical operational amplifier. and this is the non-inverting operational amplifier with practical circuit. Okay, so gain will become AV upon 1 plus AV beta upon, right, and what is the beta? This value. You have to use this. Now we will solve one question on this. This is the question here. Okay, this one. Tell me, what is the voltage gain? If suppose it is asked, then you can, what is the overall voltage gain? Then remember AV upon 1 plus beta AV. If the input resistance is asked, what is the input resistance seen by this Vin? Ideally it is infinite, but practically what is the resistance seen? Ri, that is the internal resistance of the operational amplifier, multiplied by 1 plus AV beta. If the output resistance is asked, then R naught, this is the internal resistance of the operational amplifier, 1 plus AV beta. It is divided by 1 plus AV beta. Here 1 plus AV beta is also called desensitivity. Then this is the case. And what is the feedback mechanism? Voltage series feedback. In this case, the feedback mechanism is voltage series feedback. That's why input resistance increases, output resistance decreases, and that is the gain. And phase shift is 0 degree. Phase shift is 0 degree, and that's why it is called non-inverting operational amplifier, guys. So these are the 4 important formula. 1, 2, 3, 4 regarding what non-inverting operational amplifier with practical op-amp. Then what is the differential amplifier, guys? So with this question you will get the idea what is the differential amplifier. In a differential amplifier, we are giving input to both the terminal, inverting terminal as well as non-inverting terminal, and that is called what? Differential amplifier, guys. So differential amplifier means that is the circuit. First of all, I will give you the basic idea about that. Then we will solve this question. Then in a differential amplifier, we are giving input to inverting terminal as well as non-inverting terminal, and this is the use of inverting op-amp and non-inverting op-amp. This is the inverting terminal, and we are giving the input V2 let. It is the non-inverting terminal. Again, we are giving the input at this terminal, that is R2, R3, and this is the second input V1. V1 and V2, there are 2 inputs. And that is nothing but differential amplifier, standard diagram for differential amplifier. Right, in every question, first of all, always check what is the ratio of RF by R1 and R3 by R2. If RF by R1 is equal to R3 by R2, if that is the case, then if that is the case, RF by R1 is equal to R3 by R2, it is the ideal differential amplifier. For ideal differential amplifier, the gain AD, that is called difference gain, is nothing but RF by R1. RF by R1. Output will become AD-VD, that is nothing but RF by R1. V1 minus V2, always remember that is the non-inverting terminal minus inverting terminal. And third thing, AC, common mode gain, will become 0. CMRR, common mode rejection ratio, AD by AC, will become infinite. Will become what? Infinite. So that is about what? Ideal differential amplifier. But you have to check the ratio. RF by R1 is equal to R3 by R2. Then these are the results. Okay. And this CMRR is called figure of merit of differential amplifier. But suppose if this condition not satisfied, then if that condition not satisfied, RF by R1 is not equal to R3 by R2, then you have to write the answer. Watch this, how I am going to write the answer. First of all, what is the gain of non-inverting op-amp? The gain of the non-inverting op-amp is 1 plus RF by R1 into positive terminal voltage. Let this is the positive terminal voltage VP. Minus, we are applying the superposition theorem. What is the gain of the inverting operational amplifier? Minus Rf by R1. Actually, we are adding the signal, but it is minus because it is inverting terminal. Minus Rf by R1 into V2. Right? That is the output. And what is the Vp then? What is the positive terminal voltage? According to voltage division rule, it will become R3 upon R2 plus R3 into V1. And that's why in this question, you have to write 1 plus Rf by R1 into R3 upon R2 plus R3 V1 minus Rf by R1 into V2. That is the question. And that is the complete answer for differential amplifier. This is called what? Non-inverting gain. This is called inverting gain. And then from this you can find what? From this you can find overall output when this condition is not satisfied. Now, if you have the gain, then guys, I am just giving you the idea about how to find the AC, how to find the AD, and finally how to find the CMRR. Now, if you have this gain, last one, this output, then okay, compare with this. V1 is equal to A1 V1 plus A2 V2. A1 V1 plus A2 V2. Then you will get A1 is equal to 1 plus Rf by R1 R3 by R2 plus R3. This is A1. And what is the A2? A2 will become minus Rf by R1. This is the value of the A2. Then you can find the difference gain AD. That is nothing but A1 minus A2 divided by 2. A1 minus A2 divided by 2. It will give you the difference gain. And what is the common mode gain? The common mode gain is given by A1 plus A2. Common mode is given by A1 plus A2. So that is the difference gain and that is the common mode gain, guys. Okay. So from that, if you are able to find the A1, then you can find the A2, then you can find the AD, then you can find the AC. So what is the CMRR? CMRR will become mod of AD by mod of AC. This is called CMRR. Just I am giving you the hint how we can get this formula within 2 minutes. Then get the command over that. Then how we can find that? Always remember, we are designing the differential amplifier by using two amplifiers. One is inverting, one is non-inverting, and that is the use of the inverting and non-inverting. And when we are using the summer, like this is the summer. Now we are giving the input V1, let the gain is A1. We are giving the input V2, let the gain is A2. But remember, the phase shift is 180 degree. And what is the phase shift here? 0 degree. Means we are getting the output, that is A1 V1 plus A2 V2. A2 VT. Okay. Or for differential amplifier, we are having the gain AD VD plus AC VC. That is the gain for practical differential amplifier, where VD is called V1 minus V2. And what is the VC? V1 plus V2 by 2. V1 plus VT by 2. तो बड़ा ही इंटरेस्टिंग है, थोड़ा सा डेरिवेशन भी कर लीजिए. तो देखो जरा, ये है गेन इन्वर्टिंग ऑपरेशनल, नॉन इन्वर्टिंग ऑपएम, इन्वर्टिंग ऑपएम एंड समर. ये आपका एक गेन आ गया. देन वी आर फाइंडिंग व्हाट इज द प्रैक्टिकल गेन फॉर डिफरेंशियल एम्पलीफायर, एडी वीडी प्लस एसी वीसी. नाउ कैन वी कन्वर्ट दिस फॉर्मूला इनटू दैट फॉर्मूला 1 into 2? Then yes, we can convert. How? Because let these are the two signals, V1 and V2. Then what is the difference? This is called VD. And what is the common signal? This is called V1 plus V2 by 2. This is called average value. Then what is this gap? VD by 2. What is this gap? VD by 2. So from this 2, you can write the V1 is equal to VC plus VD by 2. And V2 is equal to VC minus VD by 2. VC plus VD by 2 and VC minus VD by 2. Now we can put these two values in this equation. When we are putting the VC plus VD by 2 and VC minus VD by 2, you can get the answer in terms of what? V0. Now just I am going to put the value. Then the V0 will become A1. What is the V1? VC plus VD by 2 plus A2 VC minus VD by 2. Then you can write A1 plus A2 into VC plus A1 minus A2 upon 2 into what? VD. Right? Now you can compare with what? AD VD, AC VC plus what? AD VD. This is wanted, this is unwanted. So what is the AD? A1 minus A2 by 2. And what is the AC? A1 plus A2. A1 plus A2. So I have given the formula. This was the formula. AD and what? AC. Now, in any numerical, if any numerical is given, use this formula. If that condition is not satisfied, this condition, first of all, find the output. If the output is required, then from this find the A1, then find A2, then A1 and A2, then you can find AD by using this formula, AC by using this formula, and finally CMRR. How many students are interested to solve this question? Just I am giving you one homework. Try to solve this question and give me the answer on Telegram channel. And then I will provide you the complete solution for this. What is the question here? This is the MSQ on differential amplifier. For the operational amplifier circuit shown in the figure, RF 2 kilo ohm, R1 1 kilo ohm, R3 1 kilo ohm, R2 1 kilo ohm, that ratio is not satisfied. Not satisfied. And that's why it is a practical differential amplifier. And we are giving the same input at this terminal, same input at this terminal. This is the V2 and that is the V1. But again the output is not 0. Why output is not 0? Because it is not a ideal differential amplifier. So what will be the output? What is the differential gain of that amplifier? What is the common mode gain of the operational amplifier? This circuit. Already I have given the complete formula. Try to solve this question and give me answer on my comments box, guys. Okay then. So this is all about inverting and non-inverting operational amplifier. Try to solve this question and give me the answer on my comments box. And finally, second homework. What is the name of this circuit? Name of the circuit. Give me the answer in comments box. And finally, what is the answer for this question? IL, current through the 200 ohm resistor. A or B or C or what? D, right? Input is connected to inverting terminal, or sometimes we are connecting input to what? Non-inverting terminal. What is the name of the circuit and what is the value of the current through the 200 ohm resistor? So if have very important, a very easy question, and then give me answer on my comments box or on my Telegram channel. Okay then. So this is all about what? Inverting and non-inverting op-amp. You are on BYJU'S exam prep, the most comprehensive app for all competitive exams. Thank you and good night.